Good morning, dear students. In the previous classes, we have learnt about mortality, measurement of mortality, and we have completed crude death rate, age-specific death rate, standardized death rate. And also we have learnt about the differences between crude death rate and standardized death rate. Now we shall move on to the problems of a standardized death rate. For the following data, compute standardized death rates in two towns A and B. In which town is healthier? You need to compute the standardized death rates in two towns A and B. Which town is healthier? Students, you all know what is the formula for standardized death rate of two towns. If it was given that standardized death rate of town A, it is equal to summation of capital P into A divided by summation of P, and standardized death rate of town B, it is a summation of P into B divided by summation P, where P is the standard population, A is the A specific death rate of the population A, B is the A specific death rate of the population B. Now here we have given with the standard population and population and deaths of respective towns are given. Now we need to calculate the A specific death rate for the respective age groups of town A separately, and then you have to multiply with the standard population and then get the answer. Similarly you have to do for town A. Now we shall move on to the solution part. For town A, now we shall calculate A specific death rate for town A. A specific death rate for town A, it is given as number of deaths in a specific age group in a year divided by average population in the age group in a year into 1000. Now for the first one, that is solved, that is A specific death rate from the age group 0 to 10, it is equal to 36 divided by 4000 into 1000, which is equal to 9. Similarly calculate ASDR for 10 to 25, 25 to 60 and 60 and above. You have given with the standard population, so see the columns how it is done. So standard population is given, so multiply ASDR of A into standard population P, it will give you P into A. So 9 into 2000 will give you 18,000, 4 into 3000 is 12,000, 10 into 6000 is 60,000, 19 into 4 it is 76,000. Add standard population as well as summation P into A, you will get summation P is 115,000 and summation P into A is 1,66,000. Similarly you need to do for town B. For town B, you have to make separate tabular column and you have to find the ASDR for town B into next standard population P, then multiply P into B. See the above method, same method you need to follow for the town B. Now we shall calculate standard death rate for town A, which is equal to summation P into A divided by summation P, which is equal to summation P into A is nothing but 1,66,000 divided by 15,000, which is equal to 11.06. and standard death rate for town B, it is equal to summation P into B divided by summation P, which is equal to 1,87,000 divided by 15,000, which is equal to 12.46. Now you have to compare which town is healthier. So 11.06 is the standard death rate of town A, and 12.46 is the standard death rate of B. That means death rate is higher in town B than town A. So which town is more healthier? So town A is more healthier, since death rate of town A is lesser than the death rate of the town B. Next we shall move on to the next problem. For the following data, compute standardized death rates and the comment. They have given locality A, deaths and population, locality B, deaths and population. So you need to calculate a standard population. So students, be careful here. The deaths column has come first and population has come next. In the previous problem, population column was first and deaths was second. So when you divide directly, so be careful and see the columns properly, observe the numbers and then find ASDRs. So for locality A, we shall calculate ASDR, which is equal to number of deaths in the specific group in a year divided by average population in the age group in year into 1000. ASDR from 0 to 20, it is equal to 72 divided by 4000 into 1000, which is equal to 18. So similarly calculate for age specific death rate for 20 to 40 and 40 to 60 and 60 and above. Similarly, you write the standard population P, 6000, 12,000, 8,000 and 4,000, multiply standard population and ASDR. So it is P into A, which will give you 1,08,000, 60,000, 1,12,000, 1,72,000. So summation P into A will be equal to 4,64,000, and summation P, add all the standard population, you will get a summation P that is equal to 30,000. Next we will calculate a ASDR for locality B. Age group for the specific death rate, A specific death rate of B, it is calculated as a number of death rates in respect to age group divided by the number of population in the respective age group divided by into 1000, which is equal to 120 divided by 8000, which is equal to into 1000, which is equal to 16. 65 divided by 13,000 into 1000, which is equal to 5. 140 divided by 10,000 into 1000, which is equal to 14. 160 divided by 4000 into 1000, which is equal to 40. So next, standardized population is given. It is already given for you. So it is 6000, 12,000, 8,000, 4,000. So add all this, it will give you summation P, which is equal to 30,000. Summation P into B you need to calculate. So first multiply P into B. So it is 96,000, 72,000, 1,12,000, 1,60,000, which will give you in total 4,28,000. Now it is done. So summation P into A you have done. Summation P, it is also done. So you need to calculate standardized death rate. Standardized death rate, which is equal to summation PA divided by summation P, which is equal to 4,64,000 divided by 30,000, which is equal to 15.47. Standardized death rate of B, which is equal to summation P into B divided by summation P, which is equal to 4,28,000 divided by 30,000, which is equal to 14.27. So standardized death rate is less in B compared to standardized death rate in A. So locality B is more healthier. We shall move on to the next problem. Compute standardized death rates for following town A and B. State which town is. Now when you see this problem, you can find in town A population and deaths per thousand. Same way in town B, population and deaths per thousand is given. Now you need to think whether you need to calculate A specific death rate. What does the A specific death rate? It is nothing but the average number of deaths taken with the number of population per thousand. So deaths per thousand, it is already mentioned here. So deaths per thousand, let us solve the solution now. Deaths per thousand for a town, it is also equal to the A specific death rate of a town A. So I'll take it as A. Deaths per thousand for town B, it is given. So it is nothing but A specific death rate for town B, which is equal to B. Now you can directly solve this problem in a single table itself. no need of doing two tables, because a specific death rate is already given. Why it is given? Deaths per thousand, which means it is nothing but the a specific death rate itself. So a specific death rate is given for town A as well as town B. So directly you calculate P into A. What is the value of P? Standard population is already given. So standard population, write first age group in years, standard population, then ASDR of A, ASDR of B, then calculate P into A. P into A is nothing but 15,000 into 18, which is equal to 2,70,000. 35,000 into 10, which is equal to 3,50,000. 30,000 into 50,000 is equal to 4,50,000. 20,000 into 20, which is equal to 4 lakh. Similarly, multiply P into B, which will be given. So then add summation P into A and summation P into B. So also add standard population, which will give you summation P. So standard death rate of A, it is equal to summation P into A divided by summation P, which is equal to 14,70,000 divided by 1 lakh, which is equal to 14.7. Standard death rate of town B, kindly make the correction there. Standard death rate of town B, which is equal to summation P into B divided by P, which is equal to 17,40,000 divided by 1 lakh, which is equal to 17.4. So here standard death rate of A is less than standard death rate of B. So conclusion is that town A is more healthier. Next we shall move on to the infant mortality rate. Next we will learn about infant mortality rate. Now infant mortality rate is also one of the measure of mortality where we are going to consider the deaths of the infants. So we are going to consider the deaths of the infants. What does the infants mean? Infants means the children aged less than 1 year. The children who are aged less than 1 year, they are called as infants. Now let us see the definition of IMR, or infant mortality rate. Infant mortality rate is defined as average number of infants death per 1000 live births in a year. It is defined as average number of infants deaths per 1000 live births in a year. Next we shall see how to calculate number of deaths. IMR is equal to number of deaths among the infants in the year divided by total number of live births in the same year into 1000. IMR is equal to number of deaths among infants in the year divided by total number of live births in the same year into 1000. Next we will move on to the example. In a town in a year 62,418 live births occurred, and of these 3,207 infants died in the same year. Compute the infant mortality rate. See the formula. First write down the formula. IMR is equal to number of deaths among the infants in the year divided by total number of live births in the same year into 1000. So number of deaths is given, it is 3,207 divided by total number of live births, that is 62,418 into 1000, which is equal to 51.38, which is equal to 51.38. Next we will go on to the neonatal mortality rate. Neonatal mortality rate, it is nothing but similar to the infant mortality rate, where in infant mortality rate we consider children less than 1 year, whereas in neonatal mortality rate we consider the children or the babies less than 28 days. Less than 28 days babies are called as deaths of the babies less than 28 years are called as neonatal mortality rate. Next, now what does this mean? Neonatal mortality rate is defined as the average number of neonatal deaths per thousand live births in a year. So total number of deaths of a neonatal babies in a year divided by the total number of live births occurring in a year into 1000, where neonatal babies means the babies aged less than 28 days. The age of the babies which is less than 28 days, they are called as neonatal babies. Next we will move on to the next, that is maternal mortality rate. Maternal mortality rate is defined as the average number of deaths among mothers due to the causes relating to the childbirth per thousand births in a year. So it is defined as the average number of deaths among mothers due to causes relating to the childbirth per thousand births in a year. What is the formula for this? MMR, which is equal to total number of deaths of mother due to childbirth in a year divided by total number of births in a year into 1000. Maternal mortality rate, it is equal to total number of deaths of mothers due to childbirth in a year divided by total number of births in a year into 1000. We'll see the problem. In a community in a specific year, 4000 births occurred. In the case of 40 of above, the mothers died due to childbirth. Compute MMR. So number of deaths taken is 40 and the live births is 4000. So you need to calculate MMR. So MMR formula you know, that is total number of deaths of mother due to the childbirth in a year divided by the total number of births in a year into 1000. So 40 divided by 4000 into 1000, which is equal to 10 deaths of mother due to the childbirth. Next, the last topic of this chapter, that is a life table. Now let us move on to the topic. What is life table? Life table is a table which describes mortality and survival pattern of the population or of an individual. Life table is a table which describes mortality and survival pattern of a population of the or of an individual. We can also say it has, the life table is a tabular presentation of numerical data which describes mortality experience of cohort. It is a tabular presentation of numerical data which describes mortality experience of a cohort. So here we are going to have a table which describes what is mortality condition or mortality experience of a cohort. Now before going to the table, some of the terms we will learn some of the terms of related to life table. So life table definition is a tabular presentation of numerical data describing the mortality experience of a cohort. Now what is cohort? Cohort is a group of individuals who are born at the same time and who experience the same mortality condition. Cohort is a group of individuals who are born at the same time and who experience the same mortality condition. Next, radix. Radix is the size of a cohort. The size of cohort is called as radix, and generally the size of a cohort is 1 lakh. Next, longevity. Longevity is the expected number of years that a newborn baby would live. The expected number of years that a newborn baby would live, that is the longevity. Next, we shall move on to the uses of life table. Why this life table is used? Life tables are used by the life insurance companies to determine the rates of premium for policies of a person of different ages. Life tables are used by life insurance companies to determine the rates of premium for policies of persons of different ages. Second one, it is used for the measurement of growth of population in the computation of a net reproduction rate. It is used for the measurement of growth of population in the computation of net reproduction rate. Third one, it is used for estimating the future population. It is also used for estimating the future population. Fourth one, it is used by the government and private organization in planning healthcare, retirement age, educational program, etc. It is used by the government and private organization in planning healthcare, retirement age, educational program, etc. Last one, it is used for analyzing the effects of mortality on the age, sex composition of a population. Next, we shall learn the components of the life table. There are 8 components. First one is x, second one is lx, small letter lx, third one dx, fourth one qx, fifth one px, sixth one capital Lx, seventh one capital Tx, and eighth one small letter e into x. Now let us see the explanation. What are these components of a life table? First one, x. X is nothing but the age of a person. Age of a person which starts from 0. 0 is the age of the newborn baby. Then 1, 2, 3 and it goes on. Next, dx, the number of persons among lx, the number of persons living at age x. I0 is the radix. Lx is the number of living at age x, where L0 is the radix. Dx, the number of persons among Lx persons reaching age x who die before reaching the age x plus 1. Dx is the number of persons among Lx persons reaching age x who die before reaching the age x plus 1. Thus dx is equal to Lx minus Lx plus 1, that is the number of persons dying between age x and x plus 1. So dx is nothing but the number of persons dying between the age x and x plus 1, where dx is equal to ix Lx minus Lx plus 1. Next is qx. Qx, the probability that a person of exact age x years will die before reaching the age x plus 1. Qx is the probability that the person of exact age x years will die before reaching the age x plus 1 years. Therefore, qx is equal to dx divided by lx, which is equal to mortality ratio. Next, px, the probability that a person of age x survive up to age x plus 1. Thus, px is equal to 1 minus qx, which is equal to 1 minus dx divided by ix, which is equal to ix plus 1 divided by ix, which is equal to survival ratio. Next, sixth component, capital Lx, the number of years lived in the aggregate by the cohort of L0 persons between the age x and x plus 1. Thus Lx is equal to Lx plus 1 divided by 2, which is equal to Lx minus dx divided by 2. Capital Tx, which is equal to the total number of years lived by the cohort after attaining age x, which is equal to Tx is equal to Lx plus 1 plus Lx plus 2, so on up to it goes on. Next, Ex is nothing but expectation of life. Average number of years of a person of age x can be expected to live under the prevailing mortality conditions. Thus, Ex is equal to Tx divided by Lx. Ex is equal to Tx divided by Lx. Next, example 32. In a life table, if I1 is equal to 95,400, I2 is equal to 93,492, then calculate D1. L1 and L2 are given. L1 is 95,400 and L2 is 93,492. Then find D1. So you know the formula, that is dx is equal to ix minus ix plus 1. So d1 will be I1 L1 plus Lx plus 1. So you know the formula, dx is equal to Lx minus Lx plus 1, which is equal to, here they have asked to find d1. So substitute in the place of x as 1, that is d1 is equal to L1 minus L2, which is equal to 95,400 minus 93,492, which is equal to 1,908. Example 33. In the life table, if L1 is equal to 95,400, D1 is equal to 1,908, then find the mortality ratio and survival ratio of the first year. So you know what is mortality ratio. It is Qx is equal to dx divided by Ix. Dx is given, that is Q1 is asked to find. So why Q1? Because they have given the value of D1 and L1. So you need to find Q1. So Q1 is equal to D1 divided by L1, which is equal to 1908 divided by 95,400, which is equal to 0.02. Which implies survival ratio Qx you got, that is Q1 you got. So survival ratio P1, it will be equal to 1 minus Q1, which is equal to 1 minus 0.02, which is equal to 0.98. Next, example 34. In a life table, if L1 is equal to 95,400, D1 is equal to 1908, then find the number of years lived, that is L1. So capital L1 is Lx is equal to Ix minus dx divided by 2. So L1 is equal to L1, small letter L1 minus D1 divided by 2. Small letter L1 is 95,400 minus 1908 divided by 2, which is equal to number of life that birth, that is 94,446. Next, example 35. In a life table, if L0 is equal to 1 lakh, T0 is equal to 65 lakhs years, then find longevity. Longevity Ex is equal to Tx divided by Lx, which is equal to T0 is given, so it is E0 is equal to T0 divided by L0, which is equal to 65 lakhs divided by 1 lakh, which is equal to 65 years, which is equal to 65 years. Students, these are the question and answers which were given to you already in the video, I think so, statistics session 4. So I had got some of the complaints saying that it was not clear to you, so I have sent it here. So kindly take down these questions which are important from the examination point and solve these problems also. So this first chapter will end here, that is vital statistics. hoping that you people have cleared your notes till now, and keep your notes, those who have not done, keep your notes complete, and next class I'll be starting with the new chapter. So thank you students.